Mechanisms of homeostasis. In this new unit, we want to make sure to reintroduce homeostasis. We had already seen homeostasis at the beginning of the school year when we went over all the characteristics of living organisms. We're going to see it again because we're about to go into a couple of different human body systems. And this term of homeostasis is very important to understand, and it can be hard for students to wrap their heads around. All right, homeostasis involves keeping the internal environment within set ranges. The girl in the image is shivering because her body temperature has likely fallen below the set internal environment, or the set ranges in her internal environment. Therefore, she is shivering, generating kinetic energy and raising her body temperature. All right. Control systems have different parts, and these help maintain homeostasis. First, the sensors gather data. This is their function. Next, the control center receives that data and sends a message. Next, the communication system is going to deliver the messages of target organs or tissues. And finally, the target responds to change. To the right, we have an illustration of a very familiar mechanism, goosebumps. I'm sure all of you have experienced goosebumps. Goosebumps are a mechanism that illustrates homeostasis. Whenever our body is cold, such as this lady is, then we start to shiver. But how exactly does that happen? Well, sensors gather data at the surface of our skin. They send that data to the control center, right? Using our nervous system all the way up to our brains. Next, that communication system is going to deliver messages back out to the target organs, in this case, the skin. And finally, targets respond to change. In this case, the hair follicle muscle is going to become erect. The hair is going to stand on end. Even though goosebumps is a vestigial structure, when we had a lot more hair, our hair would stand on end to trap some of that warmer air at the surface of our skin. Now, this mechanism doesn't work as well because we don't have as much bodily hair. All right, there are two types of feedback loops. First, we will look at negative feedback loops. Negative feedback loops are necessary for homeostasis. Feedback. What is feedback? Feedback is going to compare current conditions to set ranges. A negative feedback will counteract a change. For example, in this illustration, the human is holding his breath. The body senses that the CO2 levels are rising. Therefore, that change is stopped. Control system forces exhale, inhale. Thus, the O2 and the CO2 levels return to normal. Next, we will go over positive feedback loops. In positive feedback loops, change is increased. It is not counteracted like in negative feedback loops. One example is to the left. A torn vessel will stimulate the release of clotting factors. Here in the left image, we see several red blood cells. Our body likes to stop the flow of blood by also stimulating the release of these clotting factors, which look like little spiders. They're going to catch the red blood cells in little nets and they're going to stop them from flowing out of the body. In the image to the right, we can see another example. This is pretty much the same as the image to the left, but it has been zoomed out. This is a blood vessel, and you can see the result of the clot outside of the blood vessel. Right, another example of a positive feedback loop would be growth hormones stimulating cell division.